We have reached the last topic of Chapter 3. Probably thought we'd never get here, but we're finally at the end of Chapter 3. And this is going to be a short section. This is where we're going to review our polytropic relations. And we're going to basically develop a new set for ideal gas. If you remember, we talked about polytropic relations before. We had the expression that pressure times the volume to the power of n is equal to a constant, or you could write the pressure times specific volume to the power of n equals a constant. And remember, n is a constant, it's usually given to you. Now, the polytropic process between two states can be written as P1 V1 to the power of n equals P2 V2 to the power of n. Now let's rewrite that where we have pressure on one side, volume on the other. If we do that, we're going to get P2 over P1 equals V1 over V2 to the power of n. If the ideal gas law applies, then we've got this expression here. Now, if we combine all of this stuff together, this equation with the fact that we have PV equals RT, then you can develop the following equations. And this derivation is in all of the textbooks. I don't really feel like we need to go through it on here, because we're only going to use the end result anyways. So what we're going to have is we're going to have T2 over T1, and then this is going to equal P2 over P1. The exponent for this one is going to be n minus 1 over n, and that's going to also be equal to V1 over V2 to the power of n minus 1. This gives us a set of equations for ideal gases. And this is only for ideal gas. Now let's think about one more thing. Let's think about these exponents n, that value n. If n equals 1, what are we going to figure out here? What does that tell us if n is equal to 1? So look at these equations. Plug a 1 in for n. If you notice, you're going to get a 0 in both of these exponents. So if you have a 0 exponent, that automatically makes this, for example, go to 1. So if this is equal to 1, that means T2 over T1 is equal to 1. And what kind of process is that? That's a process with constant temperature, and we talked about that in one of the previous examples. That is an isothermal process. So if n is equal to 1 in your polytropic relationship, we know we've got an isothermal process. All right, so that's the end of the notes for this section. And this was a short video. We'll cut it off here, and then we'll put the example in the next video. See you then. Have a great night.